Okay, so this is the week 3. So our first question is, to the nearest $1 cent, calculate the PV of 100,000 during 5 years' time, when the nominal over 12 months is 0.09 per annum. So, as we know, PV is equal to, oh my god, my hair, okay, future over the 1 plus I to the number of years discount. So we have I12 is 0.09, so 1 plus I, the annual I, is equal to 1 plus 0.09 over 12 to the power of 12. Where's my calculator? There it is. Okay, so solving for the annual I, the annual interest, is 1 plus. So the annual I, okay, the annual I is equal to 0.0938, along those lines. Okay, so now to answer that, just plug in the values with n is equal to 5, f is equal to 100,000. Okay, so just plug that in to 1, 2, 3 over 1 plus answer to the, double check it's 5, yes, 5. And then so the PV is equal to 63869.97 to the 0.01. So that is A. Now for B, we have D4 is equal to 0.6 per annum. So D4. So as we know, D is equal to I over 1 plus I. Now, but if we have D over D4, we need I to the 4 is 1 plus I 4 over 4. But, we need it the other way around, don't we? So we need I is equal to D over 1 minus D. But similarly, D over 1 minus D over 4. D4. So we have, what did they say D was? 0.06. So 0.06, I'll just move that over there. So 0.06 over 1 minus 0.06 over 4. 0.06 over 1 minus 0.06 over 4 is 12 over 197. And now we can just work this out the normal way, so divided by 1 plus 12 over 197 to 5 equals 7. Oh, I did that wrong. Hang on. So this is actually I4. So now I need to put it back and find, okay, hang on. My bad. 1 plus, we need the annual one. My bad. 1 plus 12 over 197 divided by 4 to the 4 minus 1. Okay, so I is actually 0.0623. So now we do the 100,000. 1 plus 0.0623. 5. I'll be using the exact amount in my calculator, but just for notation. 3. 1.06. Okay. To the 5 equals 73913.64. Okay, now for the final part of this question, C. we need I of 0.5 of t is equal to 0.04 plus 0.004 t. Okay, when you see this type of format, this is calculated simply because it's starting at t, and then it's every 0.5 years. It's simple interest, but because we are doing it over 0, 0.5, 1.0, and so on, it's actually it times and multiplies together like it's compound. So it's simple for the original, but it compounds, if that makes sense. So since it's a half year, but this is annual, you convert this into half years. So that's 0.02 plus 0.002t. So this is the actual one you use because they're in terms of different things, so you're just putting them in the right units together, if that makes sense. And then so since now this is in every half year, and the number of years you're going to have is, let me recheck the question, 5.0. So you do it annually, compound. So each individual is simple, so it's the same as like plus. So for the first one, if I sub in 0 to this, 0.02, so I'll get that, and then I times that by 1 plus, and then you find the next value. So then you sub in 0.05, and then you'd carry on until you get all the way up, and then that will give you 78. Just so, by the way, you're dividing, so this will be -1 on the end. 78, 505.50. So you do it the whole way. Yeah, okay. So this individually is simple. You can see how these are simple interest rates because it's over 1 year, so it's times by 1. But it's all of them, so then it becomes compound and you times them all together. Okay, so that's question 1. Edit crop. Under certain investment. Oh. Okay, so we have the accumulation equation of 0.04. So remember, this is simple interest. So 0.4. So it starts at t 1.2. At t 1.2, and then ends 1.6 because this means it's 0.4 away, and that's 0.4. So now we need to work out a 1.2 over a 1.6 to work out the correct thing. Now, a good thing to know that by finding them together, you just divide them. I've said that so badly. Okay, so we need a 1.2, 1.6. Now this is equal to a 0, 1.2, a 0, 1.6, 1.6. So that's just an easy way to remember it. So we can do 1 plus 0.05, 1.2, 1 plus 0.05 over 1.6. So just quickly working that out. And that is equal to 53 over 54. So now we have the accumulation of the accumulation. So now remember that this means that it is accumulated simply. So the way we do simply, it's just 1 plus the interest rate times the amount of time. Okay? So the accumulation is well, it will be the principal, but we don't have a principal payment. 1 plus I times t, because this is the simple interest formula, because effective is like is I to the t, and then nominal is like the weird, and you divide it and do it through things. We don't have that. We have simple. This is the simple interest formula. So then we have 54 over 53 for the accumulation. I can ignore the p. I don't know why my pen's glitching a bit. Hang on. Is equal to 1 plus 0.05. Oh my god. Because what am I doing? Sorry, I don't know why I said that. Is equal to 1 plus, we don't know I, times 0.4, because that's how long it goes on for. So, oh, it's also 53 over 54. I think I'm like a bit dyslexic. I can work that out. It's over 54. So minus 1. So I is equal to 0.0469. Is that right? No, it is not. What have I done wrong? What have I done? 54 over 53 minus 1. It's 54 over 53. I've written it wrong 3 times. Oh my god. So sorry, 54 over 53. Oh, because I've done these the wrong way around. It's... oh, fuck's sake. Okay, let me... I'll redo all of this quickly. Okay. Let's redo it. So we need to find a 1.2, and that is divided by a 1.6. You need the bigger one, otherwise it's a discount rate, and then it's not right. So we find that, and this will be 54 over 53, because that will be correct. And then 54 over 53 is equal to 1 plus I times 0.4, because this is the simple interest formula. So 54 over 53 minus 1 is 1 over 53. So 1 over 53 is equal to 0.4 I. 1 over 53 divided by 0.4. I is equal to 0.04717. Okay. No, that's correct. My bad. So you had to first find the A for that, and then you want to put it back into the interest rate, and you want to put it into like that interest correct answer. This just tells you some things about the question, but it also tells you what to put it in at the end. My bad. And then the next one. Okay. Now this question is about the force of interest. You can see, because this is the force of interest side. So for A, the accumulation of 1, 2. Now, important formula to know is A of this. So the accumulation of things is equal to the exponential of, and then it's just the force. So, and then it's just the integral value. So if we do the integration of 2, 1, because that's the parameters they gave, 0.06 minus 0.02t dt. okay? So obviously integrating this will give you 0.06t, I've missed a 0 here, minus 0.001t squared, and then 2, 1. So solving this, I'm just going to write it down, is equal to 0.057. So e to the 0.057 is equal to, because it's the exponential, is 1.05867. Okay, b. Now they want us to do, okay, I 0.3, so that is starting at 2.2. Starts 2.2 and then ends at 2.5 because it's 0.3 years. And remember, like the last one, you find the a first and then you convert to it in I.03 form, like how we did over here. We converted after. So first we'll find the a of that. So just like before, 2.5, 2.2, 0.06 minus 0.002 t dt, and then I'm just gonna so solve that. I can't be bothered, so just say that's x because I can't remember the answer right now. So then you will do, no, I should just work it out. Okay, I'll work it out. 0.06 times 2.5 minus 0.001 to the 2.5. Squared. Okay, so that is equal to 23 over 160 minus, because I've got to do the other one now. Oh my god. Minus 3179 over 2500. Okay, so 23 over 160 minus the answer is equal to 0.01659. That's a 5, I should probably rewrite that. 59. Okay, so now this is the a of the thing. Yes. And then you do the, so this is the a, and as you know, a is equal to the principal 1 plus, and then you do that times the interest when we don't have a principal, so we're just going to do 1 plus I times the year. I've done it wrong. 0.01659. Have I done this wrong again? I'm going to stop it.